would be, needed for someone else's question. Okay, any other questions that you might have? I want to make sure the experiment is open, and I'm going to start the experiment. So no questions? Thank you so much, Jennifer. Thank you. Solubility were not as I predicted. Can we go over why, perhaps? Okay. Thank you, Tarek. Thank you. Thank you all. But what did you expect for the solubility? When you send me an email with your questions, it looked okay. But you could ask your questions. Sure. What's the question?
Hi, Dr. Memari. I'm just going to unmute myself. That way it's a little bit quicker. Right now, I'm just looking at the results. And for example, we know that the solvents hexane and toluene are nonpolar, and our solutes, sodium chloride, urea, and benzoic acid, are polar. The one discrepancy that I found was that benzoic acid and toluene are soluble within each other because they are aromatic. However, a couple discrepancies that I couldn't figure out is why sodium chloride was not soluble in ethyl alcohol or ethyl acetate, because these are all polar.
Okay, because sodium chloride is ionic, so it's highly polar, and polar compound is ionic compound. Ionic salt is not going to dissolve in organic solvent. So maybe the polarity for that solvent is not high enough to dissolve it. Sodium chloride did dissolve in water, right?
Yes, in water it did, but it just didn't dissolve in the ethanol or the ethyl acetate.
Polarity is not high enough, so it requires to be a little bit more polar for it to dissolve.
Got it. So sodium chloride was too polar to dissolve in ethyl alcohol or ethyl acetate.
Yes, in organic solvent. Yes.
Okay. Thank you.
You're welcome. For qualitative analysis, it might show no solubility, but if you are like very careful, you might see like slightly soluble, but it's not polar enough to dissolve it or to be highly soluble.
Right. Could it also have been possible that if we would have measured the 0.1 grams with the 2 milliliters of solvent, if we actually measured it on a scale, that it would have been more accurate? Is there a possibility that then
you had to make it quantitative. That means that you have to measure exactly 0.100 gram and dissolve it, then filter it, dry the sample that is left over of the sodium chloride, measure it, and see how much of it actually dissolved. So whatever is less than 0.1 gram, then you would say that much has dissolved. But since it's qualitative analysis, we just look at the appearance of the liquid to see if it dissolves, if the solid disappears or not, or if the liquid is cloudy or not, then we would say soluble or insoluble. So for qualitative analysis, your observation satisfies the answer, if if that makes sense. So it's no need to do that, to do all that.
Is there a possibility that because it was more qualitative instead of quantitative, that the solutions could have been oversaturated or supersaturated?
Yes, you have to consider the quantity, but since apple to apple comparison, so we did the 0.1 or tip of a spatula, same amount for each of the test tubes. Then in comparison to the quantity that you had compared to the other solvents, we can say this was not soluble. The same way at we talked about the room temperature. So for all of them at room temperature, it wasn't soluble. So if you increase the temperature or if you change the quantity, it might dissolve. So when it's not soluble, that actually means that it does get saturated quickly and it doesn't dissolve.
Right, so saturation and heat could have also played a role.
Yes.
Okay, thank you.
You're welcome. Very good. Okay, if there is no other questions, I'm going to ask with the first question. Deja, can you tell me, is it Deja or Deja? I have it closed, but not so. Deja, can you tell me what is boiling point? Definition for boiling point.
It's Deja, and the definition for boiling point is just the point in which the compound, the pressure is equal to each other, to the outside pressure, basically.
The pressure or the vapor pressure from liquid?
The vapor pressure.
Vapor pressure of liquid equals atmospheric pressure. Elizabeth, we are performing the distillation today. Could you give me the steps for distillation? What are the steps that are involved in distillation process? Elizabeth? Elizabeth, are you here? No? Okay. Mariah? Mariah, could you tell me the process, the different steps, the steps involved in distillation?
Can you hear me?
Yes.
Okay. First, you heat the liquid in a flask, and then the liquid with the lower boiling point is going to evaporate first into another separate column where it's going to condense, and then it's going to collect into the second glass.
Okay, so the steps are vaporization and condensation. Those are the two change in state or the steps that is involved. First, you vaporize the liquid, vaporization happens, and then from the vaporization, it goes back to the condensation. Okay, very good. Let me mark it here, present. Okay. And now, could you tell me how many different types of distillation we have?
Anyone or?
Anam? Anam is here?
Yeah, I'm here.
Yes.
Distillation in this experiment.
How many different types of distillation was introduced in this? Fractional and?
Simple.
Simple distillation and fractional distillation. We have actually 4 different types of distillation. One is simple distillation, fractional distillation, that's the second one. Third one would be steam distillation. And last one would be vacuum distillation. Vacuum distillation is used for liquids that they have very high boiling point. What would be the benefit for vacuum distillation? Anyone for this? Because I don't know if explanation is in the book or not. What's the benefit of vacuum distillation? Or
Maybe because it occurs in a vacuum and the pressure is low, you can achieve the evaporation at the same atmospheric pressure, even though the boiling point is very high.
Okay. Alexis, can you tell me what's the relationship between boiling point and atmospheric pressure?
If something's boiling in an open container, its boiling point will be equal to the, well, it's equal to, when it boils, it's equal to the atmospheric pressure on the outside. So if atmospheric pressure is at like 1, like at sea level, then it'll be at its normal boiling point. But if the atmospheric pressure decreases, the boiling point also decreases.
Okay, the boiling point also decreases. Very good, very good. So if we create vacuum, when you create vacuum or when you apply vacuum, you're actually creating lower atmospheric pressure. So when you create vacuum, you're actually pulling off the air about from the container. So the atmospheric pressure now is going to go low. Since the atmospheric pressure goes low, then your sample starts boiling at a much lower temperature. So artificially, you're going to create that low atmospheric pressure by creating vacuum. The benefit to that would be organic molecules, they can decompose easily, same way that we talked about the melting point. When you measure it, it can cause decomposition. Boiling also could cause decomposition if it's at very high temperature. So when you create the vacuum, the boiling would happen at lower temperature, and at lower temperature, you avoid, first of all, you avoid decomposition. Second, you spend less time and less energy because you don't have to put a lot of energy to boil your sample. So that is vacuum distillation. A steam distillation, we are going to talk about it when we are covering experiment 6. And during the experiment 6, we talk about compounds that they also have high boiling point, but it must be immiscible in water because the water is going to create that vapor pressure, and the mixture is going to boil at lower than 100 degrees Celsius. So if the sample, if the oil that is not miscible with water boils at 250 degrees, when you mix it with water, the mixture is going to boil at less than 100 degrees Celsius, and that is going to prevent any decomposition. So you'll be safe with the sample. The sample would be saved. So when you have the mixture of miscible compound to miscible compound, the vapor pressure for immiscible compounds is going to add up. Okay, the vapor pressure of is going to be equal to the vapor pressure of the total of the vapor pressure of the compounds that you have in the mixture. In a simple distillation, let me go to this attendance. Antonia, could you tell me under what condition you can use simple distillation?
If the boiling points are like far apart.
And what's the magic number?
I think 80 degrees.
80 degrees, very good. So if the boiling point of compound A is different from boiling point of compound B, and the difference is 80 degree, then it's safe to use the simple distillation. I'm going to bring the diagram for setup for the simple distillation. If you have a mixture of compound A and B in the boiling flask, and you use this heating metal to heat your sample, then there is no obstacle that is going to prevent compound B, the vapor of B, going up to the condenser, right? So if A and B both evaporate, they both is going to coexist or exist at the same time in the vapor phase, and they both are going to go into the condenser, and then you receive it at the same time. So it's going to result in poor separation. So separation is not going to be sufficient. If the only way that you can keep it, if you are using simple distillation, is if you keep the B in the liquid form, so it doesn't go to the vapor phase while A with the lower boiling point is boiling. So in that case, You heat up, A would go to vapor phase, would be condensed, you collect it, then you increase the temperature, then compound B, which has higher boiling point, is going to start boiling, and then it will go to the condenser and you separate. So with the simple distillation, you have to have higher, greater difference in boiling point, and the number that it says to be is safe for simple separation, simple distillation to be used for separation of two liquid is 80 degree. When it comes to fractional distillation, you have a difference in the setup and application. Application, it would be for compounds that they have like at least 10 degree or 15 degree, and then if you have a 20-30 difference in the boiling point, you would use this fractionating column. You see, the fractionating column is inserted between the boiling flask and the distillation head. The vapor must reach the distillation head before it can go to the condenser. Now, if you have compound A and B, both A and B with the closed boiling point, they can both boil, change the vapor, and they go into the condenser. But when it goes to the condenser, compound A with the lower boiling point can move up, can boil still, but compound B, which has higher boiling point, is going to condense. The liquid only survives in a vapor phase. It changes to vapor phase, or the vapor is going to survive and be vapor or be in the gas phase at higher or boiling point of its own. If the temperature is lower than the boiling point, it will go down. So at the temperature that A with the lower point can move up, B has a higher boiling point, and it is going to hit these obstacles here. These are like objects. It could be like a steel wool or glass beads or glass extensions. That's going to, your compound is going to hit that. So the compound B is going to go down. So even though the vapor is a mixture of the two, it's going to, like this distillation, like simple distillation, is going to happen multiple times during this length of the fractionating column. Maybe at this level, which is the lower level, at this level, you have more A going up, but still some B going up. When it gets to this point, the percent of A is going to be much higher than the percent of B. Ideally, when you get to this point, you only have A going to the condenser or distillation head, and the B is going to condense and go back. So that's the role of fractionating column. It discriminates between high temperature and low temperature, high boiling point and low boiling point. It would allow the low boiling point to move up, but the high boiling would have to go back. When all of the compound with the low boiling point, it reaches condenser and it is received, then you increase the temperature. Now, when you apply more heat, the vapor of a compound with higher boiling point is going to have more energy, because you have to spend more energy to change it to vapor. So the vapor is going to have higher energy. When it reaches to condenser and it does condense, it's going to lose more heat, and when it loses more heat, the condenser is going to be, the fractionating column is going to be hot, or higher temperature, is going to reach higher temperature. And when it does reach higher temperature, and gradually the temperature of the column is going to reach the temperature of the boiling point for second compound. At that temperature, the second compound is going to survive, move up, and reach the condenser. You are going to collect it. Who has not answered? Kylie, are you here, first of all? Because we had...
Yes.
Okay, perfect. Can you tell me what's the purpose of the experiment today? So we did talk about boiling point. We talked about distillation. I want to just emphasize what is the purpose of experiment today. What are we trying to do today?
The purpose of the experiment is to purify two liquids by separating them.
Is that the only purpose? For distillation, usually that is the case. But for this specific experiment, what is the purpose? If you have looked at the procedure or what you're trying to do at the end after you collect your data, it might help.
I guess also to determine how temperature changes with volume.
That we are going to collect that as a data, but how we are using the data is slightly different. So you mentioned the two of the application. I'm just asking for just a one more thing. One more, Craig?
I'd say it's to show the differences between simple and fractional distillation in separating two compounds. As
I'm
regards
sorry.
to temperature.
So what you're trying to do between the simple and fractional distillation?
You're trying to see if there's any differences in how.
Any difference? Okay. You're trying to find out the efficiencies. You want to see which one is more efficient. Which one is going to give you better separation? Because you don't have any unknowns. You are mixing two known samples. First of all, you know that the boiling point between the two compounds is not 80 degrees, and you're trying to use the simple distillation, try to separate them. The perfect separation or better separation is this graph on the mixture Z, because when you start with the distilling the compound, the first compound, the temperature stays constant. So you have this plateau here, a constant temperature. That means only compound with the lower boiling point is coming out, reaching the thermometer. Then you would have, mixture, or you have to increase the temperature in order to get to the boiling point of the second compound. At the boiling point of second compound is going to be your second compound, boiling point of second compound, which only second compound is being condensed. So if we look at this like a perfect, so here you have your compounds that they have great difference, and your distillation method that you are using is efficient for separation. If you have two compounds with the same boiling point, or you have a compound that has a non-volatile impurities, like if you water and salt. Salt has melting point of 800 degrees Celsius, which is a very high number. Boiling point is going to be higher than that. Only water would vaporize, and you get only one compound, and the temperature should not change because the second one is not coming or joining the vapor. When you have compounds with close boiling point, you are going to get a curve, not a flat line. But if the boiling point is different, or your separation technique is efficient, you would get like a distinct line for compound A and compound B. So when you are done with this experiment, you are going to first collect your sample. Okay, so when you collect your sample and you record your temperature versus, so you have your milliliter here and the temperature for simple distillation. You have another table that you are going to record. Oopsie, my handwriting is not good. When I try to use the mouse, it's even worse. So you would use one for simple and one for fractional distillation. Then you are going to plot a graph for milliliter versus the temperature, and you would, if is ideal separation, you should get something like this. Straight line, almost. Okay, this blue color. Now, if the separation is not good, this was supposed to be straight line, then you are going to get a curve. Okay, if it's not good, you would see like this. If it's somewhat okay, you might see a better, like a separation maybe here and not good separation up there. So ideal graph for separation is going to be the blue line. The closer it is, your result to the blue line, the more efficient your separation is going to be. So comparison between the simple distillation and fractional distillation. Your lab report must include two tables, one for simple and one fractional, and two graphs. The two graphs doesn't have to be drawn on the same scale or on the same page. You could do separate, or if you want to do it separate is fine. The table and the graph, both of them, Excel is fine. For tables, you could, because it's a Word document, you can insert the table in the Word document and type in the numbers. If you want to use Excel and copy and paste, so when you do Excel, you actually do one-time typing. You just have it on the Excel form and then copy and paste into your lab report. So you do use Excel for the graphic, yes. And when you do graph, make sure that you have your X and Y axis. Make sure you have your units, like if you have a milliliter here, and if it's a degree Celsius for the temperature, so you have your numbers and units proper. Okay. Any questions? So this one kind of explaining, I explained in simple ways, and also on the board I was explaining. When you watch the video, you will see it. When you have a mixture of the vapor, this would be at the lower end of the fractionating column. At the higher end of fractionating column, you could reach to this. Basically, couple of these, couple of these steps is like multiple simple distillation. We had some questions here. Okay. We can continue with some of these questions. Anifal, are you here, first of all? Anifal? Yes? Okay. Could you tell me what's the purpose of greasing glass joints? In distillation. Oh, greasing glass joint. When you are setting up the distillation, because one purpose for this experiment is to learn how to set up simple distillation, how to set up fractional distillation. When you are setting it, you have to actually grease the glass joint. And I'm asking, what's the purpose of greasing glass joints? There are two purposes, actually. Two purposes for the greasing glass joints. Danielle, are you here? I guess. Jennifer?
To make sure that there's no air going through.
Air going through. Okay. Anifal said something about the vapor not coming out. And basically, when you have your setup, when the vapor forms, as soon as liquid changes to vapor, vapor has high energy, is going to escape the first opening that it's going to find. So if you don't grease the glass joints, there might be like an air gap or hairline, gap between the glass, the two pieces of glass, and the vapor is going to escape. As a result, is going to lower the percent yield. Usually, if it's hot, if it's inside the flask is colder than outside, the air can go in. But in this case, when you are doing distillation, because inside the system is hot, it's trying to push away the gas. Going in is not the case often, but definitely liquid water can go in, because you have the condenser. In case of water splash, water can go in. So you want to make sure that is sealed, so no air or vapor would escape, no water would go in case of water splash. That's one reason to have a sealed system. And the second reason for greasing glass joint is that to prevent freezing. That's the term that is used, freezing of two glass joints together. If you have the two glass joints freeze together, it's going to be one piece, and then you have to break one to rescue the other one, or both of them is going to be discarded. But when you grease it at high temperature, they are not going to freeze together. So one purpose would be prevent freezing of the glass joint, so you can separate easily after the heat. And the second reason is to make sure that you have a sealed system, so it doesn't the vapor does not escape, and it doesn't lower the percent yield. Okay, Ashana, what's the purpose of using boiling chips? Okay, boiling chips is going to, let me look at the response one more time. It could help to ensure a smooth process. Okay, boiling chips, what it does is going to break the big bubbles to smaller ones, so it's like a gentle boiling, smooth boiling. Very good, very good. If someone starts distillation, you heat up your system and is already hot, you realize that there is no boiling chips. What do you need to do? What do you need to do? Ashley? Tarek?
So you would have to let it.
Yes, it's Tarek. Yes.
Yeah, that's Tarek. You would have to let it cool down first, because what the lab manual said is if you toss the boiling chips in while it's already hot, then it would basically create like a severe form of bumping, where it's gonna be like violently release a lot of gas.
Very good. It can violently release a lot of gas, and the gas is not always water. Water, it can just cause burning, but if it's other compounds, they are also toxic, and you don't want to be exposed to gas, and either like being, preventing burning and other exposure, risk of the exposure. So you have to basically stop the heat, let it cool down, then you open and add the boiling chips. You should never continue distillation without the boiling chips. Very good. Okay. And there was one other thing, the water level, it should go from the lower end, and it should come out from the upper end. Any reason for that? Why water should go in from the lower end and come out?
So the reason that water should go into the lower end is because the vapor will be able to condense more easily. If it were to go in the upper end, the vapor may not reach the cold water and it might not condense. And if it doesn't condense, we could lose product because it would evaporate out instead of condensing into the graduate cylinder.
Okay, very good. So if the water comes from the top, upper level, because of the gravity, it can just fill this portion of the condenser, not the whole thing, and the condensation is not going to be efficient. So you might lose some of the vapor doesn't change to liquid, and then the vapor can escape from this at the end of the receiving. You know, this piece is called the vacuum adapter, but we just set it up here for easier collection and making the path way longer for the liquid to go down, so it cools down more. So you can lose the sample as a vapor if the condensation is not efficient. Kylie, I think you asked for question number 3. What is question number 3? If the two compounds, they have same boiling point, what happens? If they have same boiling point, it's not going to separate. Is that right? Is that the question? I think that's not the question is asking. I guess is asking if they have the same boiling point, what would happen? It could be the same. It could be the same compound, or if it has like different property, like they smell differently, if they have different density, it could be different compound, but with the same intermolecular forces, or somehow that they have same boiling point, you will not be able to separate by distillation. So distillation would not be proper method for separation of the two compounds with the same boiling point. So that could be your conclusion. Is there anyone who has not answered any question? Cassandra, you're here? I haven't called your name yet. Okay, because you're not here. Anyone who has not answered any questions? No? You all answered at least one question? Okay. You haven't. Valentino, what happens if you heat up your sample very fast, like very high temperature? You apply very high setting on the electronics and you heat up the sample very high, or fast heating, fast rate of heating. What would be the problem with that?
Well, from hearing that, I would probably say that the thermometer wouldn't be able to pick up the reading quick enough, because
that would be for melting point. That's the perfect answer for melting point.
Okay.
For boiling point. What else?
The volatile liquid, I'll denote it as A for now. The volatile liquid, if it were to boil so fast, if you speed up the process, then I don't think condensation would happen correctly if it were to go so fast, because it would just be vaporization and condensation. But I think there would be something wrong in there. For fractional distillation, probably
Okay, one point that you mentioned was correct. That is that your condensation is not going to be efficient. That means your condenser is not going to be able to condense too much vapor. If you have volume of the vapor, like massive volume of vapor, then it's not going to condense and you would lose some of the vapor. So you might see vapor coming from the end of the condenser. And if you see vapor leaving, that means the temperature is too high, you have to lower it. Other problems. What's the other problems? What are other problems? Or maybe at least one more. You're trying to separate the high temperature, high boiling from low boiling, right?
Correct, yes.
And if you heat it up too fast, what could happen?
Both A and B will boil.
Both of them will boil at the same time, and especially for simple distillation, both of them can go into the condenser. The last problem that could happen is called bumping. And what bumping is, bumping means that the liquid would jump into the condenser, and it won't change to vapor.
Yeah.
So you might see the liquid going into the condenser.
Okay, that's cool.
Okay, any questions? Elizabeth, did you answer a question? Have you answered any questions or no? Okay, no questions for now. Elizabeth, can you hear me? Think you just joined and then you had, no, you're here. You have any questions? The lab notebook for experiment 2. First of all, it looks like that we're missing few lab notebook. Remember, pre-lab assignments is pre-lab assignments. I answer a lot of pre-lab questions during pre-lab discussions. I cannot accept late submission for pre-lab assignments. The pre-lab assignments needs to be submitted before the lab starts. And if you submit it after, the grade would be like half. You start from like 50% points. So you don't want to do that to yourself. Submit the pre-lab assignments before the lab. For lab report, if you submit late, you lose point, but it's not as bad as if you were going to lose point for this one. Okay, for the lab notebook, I expect 2 tables for this experiment. 1 table for the simple distillation and 1 table for fractional distillation. I expect full sentence for the procedure. So if someone takes your lab notebook, should be able to perform experiment, because it's the if you see me taking points off from your lab notebook, keep these points in mind. It could have been that you didn't have 2 tables, or you did not write procedure. You just said, like last week, that was not for your class, but I saw someone saying, measure the melting point. Well, it's the first time you are measuring melting point. Tell me how to measure the melting point, because this is you're writing procedure. Procedure means step by step. And it's not the best time to mention this, because next week you have like general procedure, and then you have a specific procedure. Next time, for next experiment, I have to beg you to write less, because we only need the specific procedure, but complete sentence, step by step. Okay. I do have some great lab notebook completion here, and it's not just one other thing. You're not plotting graph in your lab notebook, but you need the table to record the data in your lab notebook. So I'm checking some of the lab notebooks. If you can use your mic to ask questions, I appreciate, because I don't want to miss or answer your questions too late if there's something that you need to know right away.
Oh, no, I was just, you basically answered it as soon as I sent it. It was basically, I was just saying that I drew the empty tables and the graphs, and I was just asking if
It's
they were.
okay. If you have both of them, it's okay. But if you have only one small table with like, which it wasn't in your case, I looked at it already. If you draw like a table with 3 rows and you are collecting 14 or 15 milliliters, and that's not going to be sufficient.
Yeah.
If you draw both table and the graph, it's okay. However, you don't have to plot the graph.
Oh, okay, got it. So the only
You
thing that
don't
was
have to
required.
plot the graph in your lab notebook. You only need the table in your lab notebook.
Okay, thanks.
Sure. Okay, is there any other questions? I saw a few. Oh, one other thing. And now, please, I do not want multiple submission. And I want tables, not graph. Multiple submission, that means that you have pictures, that you're submitting individual pictures. Please do not submit individual pictures. I want a PDF file, a single file to be submitted. You copy the pictures or images that you're taking into a Word document and submit into, and save it as a PDF and then submit it. Some of you have watched the experiment already. No problem with watching it, but you don't have to watch it before. You're going to watch it now, right after the pre-lab discussions. So just to give you heads up on that. Okay, so those are some of the points for the lab notebook. So you have basically you have to read the experiment and recognize what is the table that is proper for this experiment. Okay, if you don't have questions, I'm done with the pre-lab. I just have to make sure that I am going to time steps for the pictures we need to take for this lab. No, for this lab, I'm not sure. When you watch the video, it would tell you. When you watch the video, it would tell you what time. We can also use the CAM scanner, make a PDF. Yes, CAM scanner would make the PDF right away. You don't have to convert it. CAM scanner is the best way because if it's pictures, sometimes you copy the. I had it for morning class. I had the students who took the pictures, but they pasted like sideways in a Word document, and I had it's very hard for me to read. The content of the table doesn't have to be there. It doesn't hurt, but you don't have to submit it before. Okay, perfect. To take a picture for fractional distillation, then take the picture for the fractional distillation and include that and submit that to the same folder with the lab reports. So with his assignment, it takes multiple submission. So you submit your lab report and you also submit the picture for the fractional distillation. Probably starting next class, I ask for many. I would ask for many pictures, and then you have to copy them into Word document and submit it. Okay, let me call for attendance before, okay. Tarek, Ashley, what happened? Dua, I think Dua is not in this class. She's in 3:30 class. Rosie, Deja,
Here.
Ashana, Elizabeth, Jennifer, Alexis, thank you. Kylie, Caleb, okay. Valentino, Ashley M. Did we have like one Ashley who joined and left? No, Antonio. Okay, kind of. Danielle, Mariah was here. Catania, Did you answer any questions, Katania? Okay. Anifa? Okay. Katania, make sure you join and make sure your internet connection is good so you can join us from the beginning of the lab. Now, Anam, Sammy, Cassandra, not here, Craig, and Antonia. Okay. Antonia. Okay. Thank you so much. And please start watching the video. Collect your data. Use it. Thank you so much, guys, everyone. Thank you. Thank you. If you have any questions, 9 a.m. tomorrow, I have my office hours. I would be there from 9 to 10:30 a.m. Have a great day. Thank you. What's the class ID for the class ID? What do you need the class ID for, Katania? Where does it ask you for class ID? Zoom videos. There is no Zoom video. It's going to be Blackboard, Collaborate, Recording. We have like 4 of them already. And from last class. Okay, from last class, I have to make it available then. If it's not available, sometimes they change the setting for the recording. I have to go and make the recording public or give you ID.